Who would have guessed that in 2024, a whole 3 decades after these things were even introduced, we'd be getting an all-new JavaScript Cookie API? With so many storage options available to us, you might have been led to believe that cookies are somehow legacy. After all, we've got localStorage, sessionStorage, and IndexedDB, and they're feature-rich, privacy-preserving APIs. So we should be getting rid of these things now, right?
False.
Not only can it be advantageous for server or edge-side logic that our cookies are automatically transmitted with our HTTP requests, but also none of the aforementioned storage mechanisms allow for their contents to be altered by server responses. And that's a really powerful feature of cookies. The unfortunate thing is that client-side management of cookies has been a little neglected. If we pop open the JavaScript console on any website, you can see here that the document.cookie API does indeed work, but it's far from developer friendly. All we get is this one long string of cookies, so you've got to write your own parsing to read out the values. This note is the most concise example I've found, and as you can see, it's far from readable, but it does work. You can see we can only read the values here, so in the rare cases you need to read what the expiry is or any of the other flags, you're at a loss. If we want to write a value, we have to build our own cookie string and assign it back to document.cookie, which makes it look like we're going to override the entire cookies list, which is pretty awful. And as if that isn't bad enough, you can see that this API is synchronous, which might have a huge impact on performance these days, but it's still a main thread blocking activity that you need to consider. And finally, there's no way to automatically listen for changes without polling or relying on other APIs like Broadcast Channel. Thankfully, something more modern is on the horizon. The Cookie Store API has actually been around in Chromium browsers since late 2020, but I've been following its recent development in the other browser engines, and not only has it now arrived in Safari Technology Preview 204, but it's shipping as an experimental feature of Firefox 132 as well. So there's a good chance that by the time you're watching this video, it's actually been released. Cookies might almost be as old as the web itself, being introduced by Netscape in 1994. But I'm pretty excited about all the benefits of the Cookie Store API being realized across all browsers. It's a developer-friendly, promise-based API that also introduces JavaScript events for the changes. So let's take another look in our console. We can read values using the Cookie Store API. We'll need to use await here because it is asynchronous, and then we can use cookiestore.get and give it the key of our cookie. And the fantastic thing you can see here is that not only do we get the actual value of our cookie, but we get a full object giving us the description of it as well, all of the flags that might be set on it, what domain it applies to, what path it's scoped to, and its expiry. So that's really wonderful. Now, if we wanted to listen to changes to any of the cookies, whether it's this tab or another, we can do that by adding an event listener. So what I'm going to do is I'm going to open up a new BBC tab in the background, and I'm going to go back to this one. We're going to add our event listener. So I'm going to cookiestore.add event listener. I'm going to listen to the change event and just simply log them out to the console. If we go back over to this tab, I can then again use the Cookie Store API to set a cookie, call it something custom, so something custom, give it a value, my value, and we should see that pop up over here. So you can see we've now got a console log here. If we pop open change, which is the array of changed cookies, we can see that we get our cookie in the same exact format. I didn't set any expiry or anything like that, so you can see why those values are the same. And you can also see we get a deleted array as well. So anything that's just been removed, we also get in that callback. A classic real-world use case for this is e-commerce, where you might want to render a cart item count locally from a cookie so you can cache better. If you're anything like me, you'll have loads of tabs open for various products and searches across a single website. So having the cart count synchronized across all of them is ideal. In fact, this is the exact use case that I built a small demo around for my latest web performance workshop. So let's take a look. Now, this demo isn't overly complex, it's nothing fancy, But I wanted to highlight it because not only does it synchronize the count across tabs, but there's something really special if we look at the network as we make our updates. So if we open the mini bag here and increment one of the items, you can see we make this fetch request, and that's just returning with a 301 response for progressive enhancement reasons. Now you can see that the response body was completely empty. We've got the cookie that sets our cart count, and that's the bit that we wanted, that updates our element, but there's no response here. Because we're listening on that cookie, we don't need to parse any JSON, and we're not having to inject any HTML. It's as simple as that. It's a really straightforward approach. And if we hop over to our code, you can see how this works. We've got a custom element here. We're listening on that cookie store for the change event, and then as soon as we're hooking up our element, we're looking in the cookies to see if we already have a value and updating it on the page client side. You could, of course, server-side render this on top. That's completely optional. When a change event comes in, we look for our cookie based on that cookie key that we've set above, and if that appears in the change list, then we render that to the page. And when we do want to update a render, whether that's based on the initial loading of that cart count or on one of those events coming in, we request an animation frame just to try and prevent as much kind of layout thrashing as possible, and do this just before we render. And then we set the text content, which is a little more optimal than inner HTML, to this new value, and it's as simple as that. We then just register that as a custom element, and the browser takes care of the rest. Of course, in the real world, you'd likely want clearer visual feedback, and you probably want to refresh the cart contents too. But the fantastic feature that I'm focusing on here is that we have one implementation and all the tabs get updated automatically. If you've enjoyed watching this video, I'm going to follow this one up with a video on using this API to build better cookie consent banners. So if that sounds intriguing, or you just want to see whether my Monstera dies or thrives in the background, please consider subscribing to the channel. I'll see you in the next one.